In this video, I'm going to show you how to get covariance between two given variables. Covariance, as you know, measures the linear relationship between two variables, and the two variables should be numerical variables, and it measures both positive covariance and negative covariance depending on the relationship between these two variables. So how do we get the covariance? So we'll take two variables x and y. We define these two variables first, and these are numericals in nature. So we define x and y, and then how we can get covariance is by using the function COV, and to that function we'll provide x and y as parameters, and then it is going to give us the covariance for us. We can do hand computation and get the covariance, but using this function we can get it quite easily. So this is the covariance between x and y, which is 5.6. In this video I'm going to show you how to get correlation coefficient of two numerical variables in R. Correlation coefficient measures the strength of the relationship between two numerical variables. And it could be the negative relationship or the positive relationship. It can be a negative number or a positive number. It lies between -1 and +1, and we can measure it by the formula covariance of the two variables divided by the product of the two standard deviation of the two variables. Okay, so this is the formula. So we can do hand computations to calculate the correlation coefficient, but we can also get directly using a function or a built-in function. It lies between -1 to +1. If it is -1 or +1, it shows a perfect relationship, depending on obviously the sign, whether it's a perfect negative relationship or perfect positive relationship. It can be for more than two variables, but correlation coefficient is normally used for just two variables, but it can be also multivariate correlation, but that's different. So what we do first is we define two numerical variables x and y, and then we will use the built-in function core function. We'll provide x and y as the parameters to these functions, and then we'll get the correlation of these two variables. So let's run this. So as you see, the correlation between x and y is 0.79. How we should interpret it is like this. The correlation between x and y is positive. That means if x moves in one direction, y also moves in that same direction. However, slightly much less than x, because they do not move in the they move in the exact direction, but the extent is not equal to 1, but it is closer to 1, like 0.8. So that's the way we should interpret. If it is towards 1,